talking about the strength of the relationship. So we know that we can have possible correlations from -1 all the way to +1, with 0 being no relationship whatsoever, the shotgun blast on the scatter plot. So as we creep up, I want to have R values, and R is going to be the symbol for the correlation coefficient. And the one that we're going to use in this class is going to be the Pearson product moment correlation coefficient. If I have an R that's equal to 0.30, that means that 30% of the two variables share something in common. So I creep up here and I have 0.30, I have 0.50, I have 0.70, all the way up into a perfect correlation of 1. On the negative side, I'll have a negative 0.30, a negative 0.50, and a negative 0.70. So those are going to be kind of some parameters we can put on the strength of the relationship. I'm going to say that a weak correlation is going to be anywhere from like 30 below. 30 would be weak, and anything below that would be just a weak correlation. A moderate correlation, let's just go ahead and say, is going to be anywhere from like 0.31 all the way up to 0.50. And then a strong relationship is considered 0.70 and above. So my moderate basically is going to be 0.50 to 7, so 50% to 70%. A weak correlation is going to be from 0.30 to 50, so that is just going to be weak. And then we can look at the negative correlations. You may want a negative correlation. That's what you may be looking for. You can say that as I use my pain scale a lot. So I may look at people who are experiencing treatment for pain, and I may want to see if my treatment is actually effective or not. So they may report on a scale that their pain levels are, lower than traditional treatments or something like that. So I may be looking for negative numbers. So as one variable goes up, the other one goes down. The more sessions of hypnosis that they receive, the lower their pain threshold. So as one number goes up, the other number is going down, and you will have what's called a negative correlation. I'll show you what that looks like. So you have variable Y and you have variable X. Let's just say Y is going to be the pain. I can predict their pain level. So I'll have pain levels all the way from 1 to 10. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then I have therapy sessions of hypnosis. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's say that people who are experiencing 6 therapy sessions will have a score of 3. So I'll come over here and I'll plot that. Well, 1 session, they may still be reporting pretty high pain over here, so we'll plot that there. So someone who's had 4 sessions, they may be in the middle over here somewhere. And now I can see that I've got a regression line moving this way. Instead of going in a positive direction, I've got the regression line going in a negative direction. So as this X variable goes up, the Y variable is starting to come down. So that would be the relationship in those two variables. It would cause a negative relationship. So sometimes we do look for negative relationships and what the strength of that relationship may be. So if you've got a 0.70 negative relationship, that may be a good thing. Just because it's negative doesn't mean it's bad. So let's not think of negative as good and bad, but rather that as a mathematical term as just positive and negative. Okay, I want to show you There is a scatter plot that looks like a horseshoe, and this called as like a bilinear type of relationship. We can see some going this way, some going this way. You don't see this very often, but sometimes you can see a horseshoe-looking shape, and sometimes the data will be going up and then it'll drop off. So you can see that. It doesn't happen often, but just be aware that that can happen. And that would be a very lower type of relationship. So let me show you the test statistic for the Pearson product moment correlation coefficient. It's pretty, I'd say, cumbersome, to say the least. There's a lot of things going on. So let me refer back to my notes, because just when I think I have this down, I miss a component in there. So I'm going to be looking at R is going to equal N, and I'm going to be looking for the sum of X and Y minus the sum of X times the sum of Y. That's going to be my numerator. That shouldn't be too hard to get. So let me go ahead and put the second part of this down. I'm going to be looking for the N times the sum of X squared minus the sum of X quantity squared multiplied by N times the sum of Y squared minus the sum of Y quantity squared. So that's what, well, I gotta take the square root of all that, and so that's what our data is gonna look like. So let's go ahead and do our hypnosis and pain. I'm gonna hypothesize that the more therapy sessions that they have for hypnosis, the lower their pain is going to be reported. So I'm going to go ahead and put two groups here, two variables. I'm going to have a hypnosis and pain. So I've got, let's just say I've got 5 clients, and now I'm going to say hypnosis and pain. So this is going to be the amount of therapy sessions that they get. So this person has been to see me 8 times, and they're reporting a pain threshold of 2. This person comes in, they've seen me only once, they're reporting a pain threshold of 8. This person comes in and they've seen me 5 times, and they've got a pain threshold of 5. This person comes in, they've seen me 2 times, and they've got a pain threshold of 7. This person comes in and they've seen me 7 times, and they've got a pain threshold of 3. So that is my data. What I'm going to be looking to do here is I need to find the sum of X and Y. I need to find the sum of X. I need to find the sum of Y. I need to find the sum of X squared, and I need to find the sum of Y squared, the sum of X quantity squared, and the sum of Y quantity squared. So I'm going to go ahead and make me some brackets here. So this one is going to be X and Y. This one's going to be X squared. Ooh, that looks terrible. X squared, and this one's going to be Y squared. So that should give me the data that I need to fill out my form here. So this one basically X times Y, so 8 times 2 is 16. 8 times 1 is, yuck, that looks terrible. 16. Do this, make it a little easier to keep track of things. And I'm going to give you some data that you can compute. You can either do it by hand or you can use Excel. I'm going to show you how to do this in Excel too. So 8 times 1 is 8. 5 times 5 is 25. 2 times 7 is 14, and 7 times 3 should be 21. So now I've got to square each x. So when I square 8, I should get a number of, geez, is it 64? I can't even, I need a calculator now. So what I'm going to do is come in and I'm going to square each one of these numbers for x, because this is going to be my x-axis, and I'm going to predict pain, so that's going to be my y-axis. So I'm going to find the square of each one of these, and then I'm going to come over here and square each of the pain data, and I'm going to have to go find a calculator just so I'll make sure I do it right. So I will return in just a few minutes.